So here's where we're going to get a little practice, make a little more connection to what we were doing yesterday with vertex form. You guys may recall vertex form was really good for finding the vertex. Okay. So you're just going to only worry about number 1 right now. In fact, you will not have to do problem 2 because I'll be your graphing calculator. You're going to give these vertices and make them open up or down correctly. Now, do you guys remember the equation from yesterday? Yeah. Or last class? X
I think you have to
minus h squared plus k. It is in your notes, okay? I don't know if I'd go from memory. Remember, I like to stash it up here like I'm starting with x squared and then I'm moving it around. Okay, so I want a function, I suggest, vertex form, for all 3 of those things, A, B, and C. Let's go. What I'd like to do is go over A and B, because if you've got it down, these go real quick. If you don't have it down, you're going to listen to the things I'm saying, try to say okay, I get this, and then I'm going to give everybody 30 seconds or a minute to do C. Because once you've got it, it's real quick. There's nothing to take time on once you've got it. So, if my base is x squared, do I need to go left or right at all? No. So I'm just going to go plus 11 to shift the whole thing up. And I know this opens up because my A term right here is positive. It's 1. So x squared plus 11. X squared plus 11 shifts me up 11.
Wait, I thought we were...
Okay, the next one. How do I get right 7? Minus 7 instead of x squared. And then my plus 11 still has me going up. I'm positive right here, which means I'm opening up. So, 30 seconds to 1 minute to make any fixes you need to make for C or confirm that C is correct. Okay, here we go. To get 7 right, x minus 7 squared. To get 3 down, minus 3. And to get it to open down, I'm going to have a negative out front there. A negative A term makes me open down just like it does in standard form. We don't need to use graphing technology here because I just confirmed it. So next, number 3, Kieran. He is starting with, he graphed this equation right here, which we know sends us which direction? Up 1. Right there, 0, 1. Then he changed that equation to this, which we know that would send us which direction?
To the right.
Yep, 3 to the right. And that would give us this vertex, 3, 1. So next he got this new equation. That new equation's right here. And he observed the vertex is at 0 or negative 1, 0 of that equation. Okay? If negative 1 goes in, I get 0 out. He's going to try changing the squared term, x squared, to x minus 5 squared. Because in theory, in vertex form, how would that move things? 5 to the right. And in theory, he's saying if you move 5 to the right from negative 1, he would end up here with the vertex, 4, 0. Do you agree? Do you disagree? Use math to justify your answer. All right, let's take a vote. Who says it works? Who says it doesn't work? Okay, who can give me a reason why they think it does not work? Micah?
Probably because it's when x is equal to 0 or y is equal to 0 to find the x value of the intercept, and you can't really treat that as if it's addition because x gets squared and that's not a constant of proportionality.
Okay. What's another reason out there? Another reason you think it doesn't work? I don't think anybody said they think it does. Yeah, what do you think, Bob?
Well, I think that what he did was it was working maybe standard form or
Well, this is standard form. This is what he's saying right here, right? He's saying this will shift at 5 right.
No, because it's not in vertex form.
So you're thinking because it's not in the correct form, it won't do anything?
Yeah.
Okay. Hadley, what do you think? Well, the other one was like x squared plus 1, and he did x minus 3. Yeah, so the B term. Hadley's pointing out it didn't have the B term. Everybody else see that? When he did it here, no B term. So I think a really nice way to prove this won't work, by the way, is to test out this point. If it does work, what will we know is true about this xy? Will it work or not?
Yes.
If it's true, it'll work. If it's true, 0. So y would equal 4 minus 5 squared plus 2 times 4 plus 1. Would you agree? No, if it's true, will it work? Yes. If it's true, it will. Well, I get a 1 plus 8 plus 1. Does 0 equal 10? No. So I know it doesn't work then. Now, here's what I'm going to propose, though. My initial no change is x squared, right? Would you agree for my A term? So 5 to the right, I'm putting x minus 5 in for what? In for x. X minus 5 is going in for x. So check this out. If I want to shift it 5 right, x minus 5 goes in for x. X minus 5 goes in for x.
Oh, it goes in for both.
Because I need to shift the whole thing, x being my left and right.
Oh yeah, and that also works.
Then this would shift us 5 right. Now in vertex form, we don't have to mess with the second thing, right? Because in vertex form, there is no b term listed, right? It's just x minus something and then a constant. Or x plus something and a constant. So this is how we would shift 5 right. Instead of putting x minus 5 in just for the first x, I would have to do it for the second x, right? ax squared plus bx plus c. I'd have to do that change to both x values to shift it. I can't just shift one of them and not the other. Everybody good? It's kind of cool how we're moving things around. I'm going to prove it to you. I brought it up on Desmos. Let me see if I can get that to show up here for you. Boom. So here's my original function, x squared plus 2x plus 1. Everybody see red? Okay. And that has us all the way, my vertex is all the way over here at negative 1, 0. 5 right, check it out. X minus 5 and x minus 5 for both x's shifted me. 5 right all the way over here to 4, 0. Yeah.
What would have different did with Kieran?
Yeah, we can look at what Kieran did. It just won't just shift you 5 right. So if I leave this one an x, let's take a look. I like that you're asking that, Bob. Let's just leave that 2x. Way up here. 410. Okay. Yeah.
Is there have to be?
So what I'm saying is we can shift left or right in standard form as long as when we substitute one x in for something, we substitute the other x the same thing for the shift, okay? So a new way to move things around a little bit. All right, this one's pretty fun. So May is making a computer game. Maybe you think something like kind of like Scratch, okay? And it has an animation and it can use physics. This is like a peanut, and this peanut needs to jump over the wall. If it does not jump over the wall, it turns into peanut butter. It does. So as you can see, currently our function is this. Currently our function is y equals negative 0.1 x minus 18 squared plus 5. Are you guys seeing that 18.5 vertex?
Yeah.
So that vertex is a problem. It's your job to come up with a vertex with this function, our base function, that works. Now, one thing you can use to help you, if you go to the slide presentation and go to the next slide, you will see a link to a lesson where lower in that there's an applet. You can mess with those values and make it jump over and over and test. All right? So I actually want to leave it on this view. Well, you can go there actually. I can write it on the next view. Looks like this. Okay, and then on this slide is where you'll get a link. This slide is where it's linked to get the peanut jumping over the wall. So you go mess with it. I need to stay on this slide though. I think you're going to notice there's a bunch of things that work. When I did it, I did the most maybe not fun thing, but whatever. I knew if I could get my peanut to go to this vertex, I'm clear. Everybody see that? So here's what I did. I went back to my function, which was negative 0.1 times. I did x minus 22 because that shifts me right 22. And then I went up. You could go up 6, up 7, up 8, something like that. But I kind of just looked where I wanted my vertex and made it happen. There's a variety that work, though. If you shift back further, though, you got to go higher to clear. If you're closer, you don't have to go as high, right? But kind of fun is to see, how close you can cut it. Okay, before you become shish kebab peanut butter. Yeah. Oh, that goes off the screen though, my man. Keep it out. It has yeah. See if you can cut it close next. So when I look at this function tells me my vertex is how many to the right or left? 3 to the right, and then 15 down. So 3 to the right, 15 down, and then we're just gonna draw like close as we can there. There it is. Because my vertex is 315 according to vertex 1. Now for the equation, I saw some wrong answers for this. This is all right. To go 3 left, I need x plus 3.
Oh.
And then squared. And then to go up 12, it's plus 12. So I saw some minus 3s down there. I get it. Right now is a great place to make a mistake. All right. We're going to work homework to the bell.